Good afternoon, everybody. Today we'll be covering the AQA GCSE Higher Maths June 2018 paper. This is a calculator paper and the time allowed is 1 hour and 13 minutes. Let us begin, shall we? So the paper starts off with multiple choice questions. Let's cover them one by one. So question So question 1 asks you to circle the decimal that is closest to 11/20ths. So to solve that, we could simply divide 11 by 20 in our calculator, which gives us 0.55. And the closest value to 0.55 is 0.56, as it is an increase in 0.01, while 0.6 is an increase in 0.05. 0.525 is a decrease in 0.025, while 0.5 is a decrease in 0.05, which makes 0.56 the closest value to 11/20ths. Moving on to question 2, we need to circle all the integers that satisfy -2 is less than x is less than or equal to 4. So 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 the answer to this question is this last one here, as this symbol means less than but not including, so not -2, but this symbol means that x is less than or is 4. So x can be less than or equal to 4, but x can't be is greater than -2 but can't be -2 itself. So therefore this series of numbers is the answer to question 2. Moving on to question 3, we need to circle the largest number. Now this one should actually be quite straightforward if you know your mathematical notation, as as the as the dot above means recurring. So this number is basically 3.277777 all the way until the end of time. So this is the largest number, as this can be written as 3.2700 something, and this could be 3.27700. And this is definitely the smallest number out of here, since the second digit is below 7, so it's smaller than all of our other numbers. Moving on to question 4, we need to calculate the size of an exterior angle of a regular decagon, and we need to circle our answer. Now this one is going to be a bit more challenging and requires a bit more maths. So first of all, to calculate the exterior angle of a regular decagon, we need to calculate the size of an interior angle of a regular decagon, which can be given by the equation 180 degrees times n minus 2 over n, which equals to 180 degrees times 8, as a decagon has 10 sides, so 10 minus 2 is 8, and we divide that by 10. And that gives us 144 degrees per interior angle. So to calculate the exterior angle, we take 144 away from 180, which gives us an exterior angle size of 36 degrees, hence giving us our answer. Moving on to question 5. A is a common factor of 7 and 120. B is a common multiple of 6 and 9. Work out the highest possible value of A over B. So to calculate said highest value, we need to have the greatest value of A over the smallest value of B, which is another way to say highest common factor over lowest common multiple. As A is a common factor of 7 and 120, while B is a common multiple of 6 and 9. So to find the highest common factor of 72 and 120, we first state the factors of 72 and 120, so the prime factors to be exact. So 72 is 2 times 2 times 2 times 3 times 3. You could figure that out on your calculator, or you can just understand that 72 is 8 times 9, which can be simplified into this. While 120 is equals to 2 times 2 times 2 times 3 times 5. Once again, you could use your calculator to try to divide these numbers by prime factors, or you can use your mathematical knowledge to break down larger factors of these numbers into their said prime factors. So to find the highest common factor, we we take the common we take the common prime factors and use that. So both equations have 2 times 2 times 2 times 3, while only 72 has another times 3, while 120 has a times 5. So 2 times 2 times 2 times 3 is a common factor in both of these numbers, and hence our highest common factor, which is 24. Next, we find the lowest common multiple of 6 and 9. To find this, we are going to use prime factors yet again. So 6 is 2 times 3, while 9 is 3 squared. Using this information, we can figure out the lowest common multiple by taking the highest power of each prime factor from the below numbers. So 6 has 2, while 9 has 3 squared, which is a greater power of 3 than 3. So the lowest common multiple is 2 times 3 squared, which equals to 18. And to figure out A over B, we could write 24 over 18, which is equal to 4 over 3, hence giving us our answer. Moving on to question 6, we have two mathematically similar shapes. B is an enlargement of A with scale factor 1.5. Find out the values of X, H, and W. So first of all, since these two shapes are mathematically similar, the angles must also be the same. Therefore, X is equals to 54. Simple as that. However, the values for H and W might not be as easy to figure out. To figure to figure the length of H, we know that B is an enlargement of A with scale factor 1.5. So H is equals to this length on shape A, which is 5 centimeters, times a scale factor of 1.5, which gives us 7.5 centimeters for this length, the length H. For length W, we do the opposite. We divide the same length on shape B, 9 centimeters, by the scale factor, 1.5, for the original shape, the smaller shape, shape A. And this gives us a value of 6 centimeters for W. This gives us all three values needed for this question, hence answering this question. Moving on to question 7. Here there are two investments, investment A and investment B. Investment A states that you can save £150 per month for 2 years, and 2.5% of the interest is added to the total amount saved. While investment B states that you can invest £3,500 and compound interest is added at 3% per year. So to find out the value of investment A, we can it is an investment is that is that is changed per month. So £150 is added to the investment per month for 2 years. So we have 2 years, each with 12 months, so 2 times 12. And each month you get £150, so times 150. And you can multiply all that by 1.025, which is the 2.5% interest added to the total amount saved. This gives the value of investment A as 3,690 pounds. For investment B, we can simply use our compound interest equation where we multiply 3,500, the principal or initial amount, by the percentage interest, or 1.03, which is 3% every year, then add an exponent of 2, since it is invested for 2 years. This gives us an answer of £3,715.15. Using both of these values, we can figure out how much more investment B is worth than investment A by taking away 3,690 from 3,713.15 pounds. So calculating this, you get a difference of 23.15 pounds, giving us our answer. Moving on to question 8. It is a question with 2 parts. Question 8a and question 8b. Actually, is there a C part as well? No, there's no C part. So 8a and 8b. And we need to solve each one individually. So first of all, we need to show that the lines y equals to 3x plus 7 and 2y minus 6x equals to 8 are parallel. And we are not allowed to use the graphing function on our calculator. So to solve this, we could arrange 2y minus 6x equals to 8 from general form to gradient intercept form. So first of all, we can divide all variables by 2. So we have y minus 3x equals to 4. Then rearranging it to gradient intercept form, where we have y equals to 3x plus 4 by adding 3x to both sides. Once we found the equation of the line, we could state that the two lines have the same gradient. Therefore, therefore, they are parallel. As if you remember from, as if you remember, lines with the same gradient are parallel. Therefore, y equals to 3x plus 7 is parallel to y equals to 3x plus 4. Now moving on to question 8b. We have we are given a question. Is the point -5, -6 above, below, or on the line y equals to 3x plus 7? And we need to tick one of the boxes below. So it's either above, below, or on the line. We must show our working, and we are not allowed to use the graphing function on our calculator yet again. So back onto MS Paint. We could figure this out by finding the the point on the graph where x equals to -5. So when x equals to -5, y equals to 3 times 5 plus 7 times -5 plus 7, and y equals to -8. So the point on the graph is -5, -8, which has the same x value as point -5, -6, but a different y value. The y value of -5, -8 is is lower than the value of -5, -6, which means that -5, -6 must be above this point, therefore being above the line. Uh, Moving on to question 9. The cost of a ticket increases by 10% to £19.25. Work out the original cost. So, so for this question, we first of all we need to show to the examiner that we understand what we are doing. So we know that £19.25 is equals to 110% instead of 100%. So 100% would be the original cost, and an increase by 10% would be 110%. Therefore, the original cost can be figured out by dividing £19.25 by 1.10, which is a way of stating 110% in decimal form. And this gives us a value of £17.50, giving us the answer to this question. Moving on to question 10. The nth term of a sequence is 12n minus 5. Work out the numbers of the sequence that have 2 digits and are not prime. To do this, we must the only way to do this is to list all the values in the sequence less than 100. So let's start with n equals to 1, which gives us 7. Then n equals to 2, which gives us 12 times 2 minus 5, if you calculate it correctly, would be equal to 19, and so on and so forth. 31, 43, 55, 67, 79, and 91. The last value of the sequence below 100. Using this, we need to find which numbers are have 2 digits. So first of all, we could cross out 7 since it's a 1-digit number. But next we need to find the prime numbers, which is not as easy as you think. So first of all, 19 is a prime number. 31 is also a prime number. 43 is a prime number as well. But 55, as it ends in 5, it's not a prime number. Therefore, we can continue. 67 is, it looks like it's not a prime number, but it actually is a prime number, especially if you experiment using your calculator. 79, a prime number. 91, it's actually not a prime number, even if it looks like one on first glance. So um so the so you could some students may be easily fooled by some of the bigger numbers, as some of the bigger numbers may not actually be primes but look like primes, like 91, which is actually 13 times 7, while 55 is obviously 5 times 11, meaning that 55 and 91 are the only two numbers that fit this rule, both 2 digits, non-prime. Moving on to question 11, we are given three vectors, it seems, and we need to work out a plus b plus c in part A of this question. So, so to work this out, we could we simply just need to add these three vectors together, which and vectors can be added using, well, simple addition. So you add 6 and -1 and -4 and 10 and -2 and 7, where you get where the top number is is 1 while the bottom number is -1, giving us the answer 1, -1 for a vector. Understood? Great, let's move on. Question 11 has a part B as well, and we need to show that A plus 2C is parallel to B. So we can add A and 2C together. To recap, A is 6, -10, B is -1, 2, and C is -4, 7. So first we should figure out A plus 2C, which is 6, -10 plus -4, 7. 6 minus 4 is 2, so the top value is 2. While, no, a- actually 6, -6, 10 plus 2, -4, 7. Almost forgot that. So we have 6, -10 plus -8, 14, which gives us 6 minus 8 is -2, while -10 plus 14 is 4. So we are given a vector of 2, 4. And 2, 4 and -2, 4 can be rewritten as 2, -1, 2. And that, if you remember, -1, 2 is the vector for B. So A plus 2C equals to 2B. So we can write that A plus 2C equals to 2B, and this states that A plus 2C is a multiple of 2B, which means that A plus 2C is parallel to B. Actually, A plus 2C is a multiple of just B, not 2B. So we can write that A equals to 2C equals to 2B, or A plus 2c is a multiple of b. Therefore, actually just write 3 dots. Therefore, a plus 2c is parallel to b. There are points for explanation in this question. Therefore, you should actually try to explain it clearly how a plus 2c is parallel to b after figuring out that a plus 2c equals to 2b, or you might not get a mark since that's what they're asking for, I guess. Moving on to question 12. Pressure equals to force over area. A force of 14 newtons is applied to an area of 3.2 square meters. Work out the pressure. Give the units of your answer. Um, so, so we can simply use this formula to figure out that the pressure is 14 newtons over 3.2 square meters. Putting that into your calculator gives you 12.5 newtons per meter squared. And if you remember correctly from physics, that is if you take physics. So if you take physics, you know that newtons over meter squared is the same as writing 12.5 pascals. In the mark scheme, both of these are accepted. So use either one. If you only use the pascal one if you're confident with your unit conversions though. So if you're not sure how many newtons per meter squared are in a pascal, maybe just leave it in the original form. Moving on to question 13, we are given a multiple choice question where we have to tick all statements that are true for any rhombus. So we have to use our mathematical knowledge, our geometrical knowledge of the properties of a rhombus to figure this out. So what we know is that all four sides of a rhombus are equal. So therefore, the diagonals are lines of symmetry. The diagonals also bisect each other at the middle. And the diagonals are perpendicular, as this is a regular quadrilateral, so the distance between corners is the same from all sides. Therefore, the diagonals are both perpendicular. However, the diagonals do not necessarily have to be equal in length, especially with longer lengths of rhombuses. So like this, like this, like this, like this, the diagonals can be of different lengths. So the last one is not true. And this is the answer. The first three options and not the last one. Moving on to question 14, we need to draw the graph of y equals to 0.8x, or 0.8 to the power of x, for values of x from 0 to 6. So we simply just put 0.8 to the power of 1 to the power of 2 to the power of 3 and so on on our calculator to figure out the values of each value of 0.8 to the power of x. So x equals to 0, anything to the power of 0 is 1, 0.8 to the power of 1 is 0.8, 0.8 squared is 0.64, 0.8 cubed is 0.512. To the power of 4, that will be 0.4096. Next is 0.5 3, 2, 7, 6, 8. And the last one, 0.8 to the power of 6 is 0.262144. So now what you need to do is to graph these values onto our graph. So so when x equals to 0, y equals to 1, so 0, 1 here. Then we have x equals to 1, so this here, and y equals to 0.8, so this point over here. The next point is 2, 0.64, so 0.6, 0.62, 0.64, then 0.512, so 0.5, 0.52, so 0.512 is around here, then 0.4096, which is 0 0.4 around here. Next, for 5, we have 0.32768, which gives us this value roughly here. And the last value is 0.262144, which for the x value of 6 gives us, well, gives us this point here. After you've found all the points, you can draw a line of best fit through these points, which will look like a curve that is gradually flattening out. So a curve of best fit will look something like this. Obviously in the exam you'll be using paper and pencil, so it's a bit different. Moving on to which question are we on? Question 15. Amy has X beads. Billy has 3 more beads than Amy. Carly has 4 times as many beads as Billy. Circle the expression for the number of beads that Carly has. So this is another of those worded problems where you're introduced to multiple characters and each of them have some kind of mathematical property attributed to them. So Amy has X beads. Billy has 3 more beads than Amy. So Billy has X plus 3 beads, while Carly has 4 times as many beads as Billy. So Carly has 4. Let's call Billy's number of beads B. So Carly has 4B, the amount of beads, which equals to 4 brackets X plus 3 close brackets, which is this expression over here, giving us our answer. Moving on to question 16, we are given 2 straight lines that intersect at point A, and we need to calculate the coordinates of point A. To figure this out, we simply write that negative 4x equals to 3. Since both are intersecting at the same value, so the same y value, therefore 4x equals to 3 since the y value is the same. So we can rearrange this to x equals to, dividing both sides by negative 4, negative 3 over 4. And since there's only one given coordinate option that has negative 3 over 4 for their x value, the first one, negative 3 over 4, 3, is the correct answer for question 16. Moving on to question 17. You're given 2 methods to make a 4-digit code, and the codes can have repeated digits. So method A, the first 2 digits use an odd number between 30 and 100, and the last 2 digits are a multiple of 11. So So we have 4 digits in total. So we have grouped into 2 units of 2 digits, while method B has states that we have to use 4 digits in the order even, odd. So 4 digits grouped into 4 groups of 1 digit. And we need to work out the method that gives the greatest number of possible codes. And we must show our working. So, so first of all, to figure out the number of odd numbers between 30 and 100, take away 30 from 100, which gives you 70. So if there are 70 numbers in between 30 and 100, but they're asking for odd numbers, so only half of these 70 numbers are odd numbers. So 70 over 2 equals to 35 odd numbers between 30 and 100. While for the last 2 digits, we have to use a multiple of 11. And if you know, and if you know your maths, there are 9 multiples of 11 between 0 and 99. So 11, 22, 33, 44, 55, 66, 77, 88, and 99. 9 multiples of 11, which are 2 digits long. So for method A, the number of different codes is 35 times 9. So so you can choose between 35 different odd numbers between 30 and 100 and 9 numbers that are multiples of 11. So the probability for A is 35 times 9, which gives us 315 number of possible codes. For method B, the number of even numbers, non-zero even numbers that are one that non-zero even numbers that are 1 digit. There are only 4 of those: 2, 4, 6, and 8. Well, there are 5 odd numbers between 1 and 9. So 1, 3, 5, 7, 9. So 4 even numbers, 5 odd numbers. So this is the number of possible digits you can use. So the probability of B is 4. 1 of 4 even numbers times 1 of 5 odd numbers times even numbers again times 5 odd numbers again, which gives us 400 different combinations. And therefore, B gives more possible codes, since 400 is greater than 315. Moving on to question 18, we need to show that for x is not 0, x plus 4 over 3x plus 5 over 2 minus 5 over 2x can be written in the form ax plus b over cx, where a, b, and c are integers, or basically whole numbers. So so um so we can multiply both of the denominators so that we can no both of the numerators so we can have the same denominator for both fractions. So we can multiply x plus 4 over 3x by 2, which gives us 2x plus 8 over 6x. Then we can multiply minus 5 over 2x by 3, which gives us negative 15 over 6x. And now the denominators are the same, so let's use a different color. Since the denominators are now the same, we could we can group the two fractions together. So we can have 2x plus 8 minus 15 over 6x, which gives us 2x minus 7 over 6x after grouping the constant values together. Moving on to question 19, which is a multiple choice question. the equation of a straight line 3x plus 2y equals to 24, and we need to figure out at which point does this equation pass through the x-axis. So an, e- when a point crosses the x-axis or a line in general, the value of y is 0. So we can first of all eliminate those with non-zero values of y, so not this or not this either, giving us two options, 12, 0 or 8, 0 for our coordinates. So since y equals to 0, we can substitute that into our equation. So 3x plus 0 equals to 24. Since anything multiplied by 0 will make 0, so 3x equals to 24. Therefore, x equals to 8. And since 8 is 24 over 3, so therefore, since the x value is 8 and the y value is 0, the point is 8, 0, which is this last option over here. Moving on to question 20. All dimensions here are in centimeters, so it just states that. So so you know that all of these, so you don't have to do um unit conversions for this question. So we are given the lengths of different points of this, of different lengths of different sides of this right angle triangle, so x, 7x, and 10y, and we need to use Pythagoras' theorem to figure out the exact value of x over y. So what we need to do is swoops, swoops. So what we need to do is is um is we should write out the pi the we should write out Pythagoras' theorem first. So a squared plus b squared equals to hypotenuse squared. So this is the hypotenuse right over here. So x squared plus 7x squared equals to 10y squared. Given this, we can expand the bracket. So x squared plus 49x squared equals to 100y squared. So 50x squared equals to 100y squared. So what we can do is divide both sides by y squared, so x squared over y squared, and divide both sides by 50 as well. So x squared over y squared equals to 100 over 50, which equals to 2. And since this can be grouped into x over y squared equals to 2, we could state that x over y without the square is the square root of 2, hence giving us our answer. Moving on to question 21. The mass of an ornament is in m grams. The height of the ornament is h centimeters. M is directly proportional to the cube of h. Work out an equation connecting m and h. So this question is a question about direct proportionality, or just proportionality in general. So a common rule we can write is m equals to a constant times h cubed, since m is directly proportional to the cube of h, not h itself. So now we substitute our values of m and h into this equation. So 1600 equals to k times 8 cubed, which is 1600 equals to um equals to 512k. Therefore, k equals to 3.125 after dividing both sides by 512. Therefore, our equation, substituting the value of k, is m equals to 3.125 h cubed, giving us our answer. Moving on to question 21, part B, we need to work out the mass of an ornament of height 12 centimeters. And we need to answer this in grams. So we can use the equation we obtained from question 21A and use that on question 21B. So we know that m equals to 3.125 h cubed. So m equals to 3.125 times 12 cubed, since the height is 12. Therefore, if you put all this into your calculator, you can figure out that m is equals to 5,400 grams right here. Moving on to question 22. A, B, and C are points on the circle. DCB is a straight line. PAQ is a tangent to the circle. Sam is trying to work out the size of angle M. Here's his working. Angle ACB equals to 56 degrees. Angles in the same segment are equal. M equals to 180 degrees minus 56 degrees. Angles at a point on a straight line add up to 180. Therefore, M equals to 124 degrees. And we need to make a criticism of his working. Like, what one criticism, so 1 mark. There's actually nothing wrong with his calculations. M is indeed 124 degrees. However, his explanation is incorrect. So, one criticism you can make, well, the only criticism you could make from this, is that he stated the wrong theorem for this first step. The theorem is angles in an alternate segment. No, angles in alternate segments are equal. However, he stated that angles in the same segments are equal, which is the wrong theorem, although he applied the right theorem right here. So, the criticism is that he used the wrong theorem, stated the wrong theorem in his explanation. And that's the answer for question 22. Moving on to question 23. A sequence of numbers is formed by an iterative process, so a recursive sequence. Un plus 1 equals to 3un plus 1. U1 equals to 4. And we need to work out the values of u2 and u3, so the next values in this sequence, which require the previous value in the sequence. And we are given the first value, so we can figure out the second value and figure out the third value from the second value. So u2 equals to 3 over u1, which is 4, plus 1, which equals to 3 over 5, giving us our answer for u2. Well, for u3, we have to figure out 3 over u2, which is 3 over 5, plus 1, which is 3 over 8 over 5. And using the rules of fractions, we know that dividing by a fraction is the same as flipping the numerator and denominator and multiplying it. So 3 times 5 over 8 equals to 15 over 8, giving our value for u3. Moving on to question 24. A speed time graph shows 20 seconds of a car journey. Harry wants to estimate the distance the car travels in this time. He uses a triangle and a trapezium as shown to estimate the area under the graph. Complete Harry's method to estimate the distance the car travels. So the speed time graph. So we need to figure out the area of this triangle and this trapezium. So to find out the area of the triangle, we use 1/2 base times height, which is 1/2 times the base, which is 0 to 10, so 10, times the height, which is 20. So 1/2 times 10 times 20 equals to 100. So 100 meters traveled by using the triangle area of this graph. While for the trapezium, the 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 area of a trapezium is defined by side A, so side A, side B, A times B divided by 2 times the height. So this is the height. So we have 20. Actually, it's A plus B. A plus B over 2 times height. And height is here, of course. So So what we can do is side A, 20, plus side B, which is 30, according to this graph, of course. Divide that by 2, then multiply it by the distance between 10 seconds and 20 seconds, so 10. So 20 plus 30 over 2 times 10 equals to 25 times 10, which equals to 250 meters traveled. So using both of these values, we can figure out that the distance the car travels is 120 plus 250 meters, which equals to 350 meters, giving us our answer. This question has a part B. So we need to figure out for this journey which of these true is for Harry's method. Tick one's box. It works out an overestimate of the distance, it works out an underestimate of the distance, or it works out an overestimate of the or an underestimate of a distance. So looking at our graph again, you will see that this entire area is unaccounted for using Harry's method. Therefore, Therefore, it works out an underestimate of the distance since parts of the graph are not accounted for. Moving on to question 25. A, B, C, D, E, F is a triangular prism which represents part of a hill. ACBF is a horizontal rectangular base, while D is vertically above C. And we need to work out the height of CD. To work out the height of CD, we must use trigonometry, albeit, well, simple trigonometric rules. So we know the angle here is 6 degrees, so 6 degrees, and we need to figure out CD. So we know the adjacent to the angle, and we need to figure out the opposite. Therefore, tangent is the most fitting trigonometric function. So the tangent of 6 degrees equals to opposite over adjacent, which is CD over 500. So CD equals to 500 times tan of 6 degrees. And 500 times the tan of 6 degrees, if you calculate it correctly, gives you, well, if you calculate it correctly, it gives you CD equals to 52.6 meters, giving us our answer for part A. Although you should keep the the full value of CED, well, this is the value rounded to 3 decimal places, but I should keep the full value of CED, which is something around 52.55 something 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 on your calculator, as it is used in part B of this question, which requires you to use the length from part A and figure out a different length, actually an angle. So question 25B states that Jamil walks a straight line from A to D. Work out the size of angle DAC. You must show your working. So, okay, we know that this side is 52.55 something 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 meters. So first of all, to find out the size of angle DAC, we should find out the length of AC. So this length over here with AB and BC. So the length of AC can be figured out using the Pythagorean theorem. So AC squared equals to 400 squared plus 500 squared, which gives us 410,000 for the length of AC squared. So the length of AC itself is around 640.31 something 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 meters, of course. So also save that value on your calculator. So for the next part of this question, we need to figure out the angle DAC. So let's draw an extra line from D to A. So we need to figure out this angle over here. And since we already have two sides, the opposite and the adjacent of DAC, we can figure out the length of the size of angle DAC by stating tangent x equals to, well, the opposite, or 52.55 something something something, over the adjacent of x, or 640.31 something 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 meters. And therefore the angle x is equals to arctan this thing over here. So 52.55 over 640.31 something something something. So plug this all into your calculator and we'll give the value of give the value of x as 4.69 degrees, giving us our answer. Moving on to question 26. This histogram shows information about the speed of cars as they pass a checkpoint. The scale on the frequency density axis is missing. The histogram shows information about 480 cars. How many cars does the first bar represent? So this is another graph interpretation question, and there are actually a variety of ways to solve said question. But the simplest way probably is the counting squares method. So we count the number of squares in each bar. So this bar has 1, 2, 3 squares, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. So 15 squares in this bar. And this taller bar here, there's the width of 1 square. So 1 square is, well, 5 meet an increase in 5 miles per hour. So you have 1, 2, 3, 4, 5. No, wait. 1, 2, 3, 4, 5, 6. And then this part here, so 6.2, 6.4, 6.6 squares. So this one is 6.6 squares in size, while this last part, each of these each of these is zero point 0.8 squares, zero point 0.8, zero point 0.8. That's so 0.8 multiplied by 3 is 2.4. So this is 2.4 squares in size. So now we have the squares figured out. We add the number of squares together. So 54 plus 6.6, 54 plus 6.6 plus 2.4 gives us a total of 24 squares used in this graph. So the first bar is 15 squares out of these 24 squares. And we can divide 15 by 24 to give us 0.625, which is the percentage in decimals that this bar occupies for this histogram. So so to figure out the amount of cars in this bar, we multiply 0.625 by the amount of cars, or 480 cars, which gives us a value of 300 cars in the first bar. Moving on to part B of this question, we we have we have this. Cars with a speed greater than 40 miles per hour are over the speed limit. Use the histogram to estimate the number of cars that are over the speed limit. So so let's paste this here. So the speed greater than 40 miles per hour. So 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 speeds from here to here. So this area here would be 2/3 of 2.4, which is 1.6. So yes, so this area here is 1.6 squares. So 1.6, so 1.6 over 24 gives us a fraction of 0.06 recurring out of 1 for the percentage of cars that are over the speed limit. So lastly, we multiply 480 by this decimal 0.06 recurring over here to get the answer that 32 cars are over the speed limit, giving us our answer. Moving on to question 27, the penultimate question in this paper. A bag contains 30 discs, 10 red, 20 blue. One disc is taken out at random and replaced by two of the other color. Another disc is then taken out at random and replaced by another two of the other color. And another disc is taken out at random. And we need to work out the probability that all three discs are red. So for the first disc, the probability is 10 over 30 since there are 10 red discs and a total of 30 discs. And we need to multiply this by the probability of the second disc being red. So after the red disc is removed, we have 9 red discs left and 29 discs in total. But two of two discs of the other color are replaced into this bag, so we have 29 plus 2, or 31 discs in the next draw. And in the last draw, we repeat this process, so one less red disc would be 8 red discs over 32 discs in total. This can be simplified to 1 over 3 times 9 over 31 times 1 over 4, since yes, 32 divided by 8 is 4, therefore this is 1 over 4, and 30 divided by 10 is 3, so this is 1 over 3. And multiplying all these together gives us an answer of 9 over 31 times 12, which is 372. And we can divide the top and bottom by 3. So the answer is 3 over 124, which is the most simplified fraction and hence the answer for this question. Moving on to our final question, P is a point on the circle with equation x squared plus y squared equals to 80. P has an x coordinate of 4 and is below the y-axis. Work out the equation of the tangent to the circle at P. So so this is a 5-mark question, probably the biggest question in this entire paper, and is worth the most marks probably. So this question requires multiple steps. The first step is to substitute x with 4 in this equation since the x coordinate is 4 for point this one. So 4 squared plus y squared equals to 80. So y squared equals to 80 minus 16. Y squared equals to 64. And 64 is 8 squared. So y equals to plus or minus 8. Since this point here is below the x-axis, y equals to negative 8 instead of positive 8 in this case. So the coordinate is 4, negative 8. Using this coordinate, we can find the gradient of the radius. So rise over run. So negative 8 over 4 gives us negative 2, which is the gradient of the radius here. So this line has a gradient of negative 2. But we're trying to find the equation of the tangent to this point. So the gradient of the tangent is perpendicular to the gradient of the radius. So the gradient of the tangent is negative 1 over negative 2, or the negative reciprocal of the gradient of the radius, which gives us a gradient of 1 over 2 for the tangent. Now we know that the tangent has an equation of y equals to 1 over 2x plus c. Using this, using a different kind of formula, the point intercept form of expressing a graph, which is written like this, we can figure out the y-intercept, or hence the last part of the equation for the tangent. So y minus negative 8 equals to 1 half x minus 4. Since we know that the point is 4, negative 8, so we substitute 4 and negative 8 here. So y plus 8 equals to 1 half x minus 2. Y equals to 1 half x minus 10, giving us our answer. And that is in fact the end of the paper. Let us see. Yes, there are no more questions in this paper, hence we have finished this paper. And now I will show you the mark scheme. Pause anytime you like and check your answers, and also see which parts you didn't get for this paper. So I will switch to the mark scheme now. So here we have the mark scheme. I will just scroll through it and you can pause it anytime you like. So you have some technical definition terms at the top, and then you have the mark scheme itself. And that is all for today. Thank you all for watching and see you all. Goodbye.